Welcome back to part 4 of 4 of this, what I think is pretty awesome series, how to connect your test gear to your stereo gear, and then I guess back into your test gear. This video series was inspired by a viewer's request, and as I stated in part 3, I actually like this. This is kind of cool. Today's subject is going to be equalizers. How do you hook up an equalizer to test it or confirm that maybe it's working properly? Well, we're going to find that out in this episode. The test gear that we're going to use today is going to be a frequency counter. Now we are using audio range, so we're going to be working within the 20 Hertz to 20,000 Hertz. So frequency counter, all your test gear is going to be in that range. It's okay if it goes over the range. It just means you can go a lot more. I guess what I'm trying to say is your test gear does not have to be too much, just to cover the audio spectrum, and that's all we need. We're going to use a function generator or a audio function generator. Of course, we're going to use a equalizer, the star of the subject. We're going to use a oscope, and we're going to use a sensitive AC voltmeter. And the cables we are going to use are RG316 with BNC connectors on either end, and on the end that's connecting to the equalizer we have a BNC to RCA mel phono connector. And since our generator is mono, it really doesn't matter what in your equalizer it's connected to. The only time that becomes an issue is if we see one of the channels on the oscope outputting a higher or lower frequency. Now, I goofed up because I got half of the cables we need. I only got the cables that go from the equalizer to the oscope. I forgot to get the source cable from the audio generator into our equalizer. Stand by one moment while I get that all hooked up. Okay, I have my source cable, and as you can see we are using RG59U, and at either end we have a mel RCA connector. So on one end we're going to take a RCA to BNC adapter and plug it in, and then on the other end we're going to take this RCA female that ports out to 2 RCA mel, and then we'll plug that in on the end that goes to the stereo, or the in this case the equalizer. And so we'll take this cable, plug it in here, and try to wrangle the wire. And then on this side, let's see, let's go ahead and hook up all of our cables. So the cable that's coming from the audio function generator is going here where it says main in, and again it doesn't matter what goes where because that's just a Y connector. Okay, got that in, and then we're going to take the cable for the scope, and we're going to plug that in to our output. Apologize for the camera work, but I don't have a crew. Okay, so they're in there good and secure. As I've stated in the previous videos, make sure you're working with good cables, because inferior cables can cause odd readings. Now, this equalizer has been in storage for about 3 years with most of the test gear that we've demoed in this series. So we're going to fire it up for the first time and see what happens. Now, this is a 10-band graphic equalizer. These controls, if I remember right, illuminate, and then we actually have spectrum analyzer here. And so we have our left and our right, and then we got some function switches over here. And since it's been 3 years since I've dorked with this, I may have to configure my input-output in the rear to achieve what we're doing, I think. We'll find out. So let's go ahead and turn this on. Come down to here, and we'll monitor both the equalizer and the spectrum analyzer. Alright, so we do have a display, and of course nothing here. Oh, okay. So after hitting my auto configure button, we do have a signal, which I didn't think we would get a signal for where the audio generator is configured. Now, if you don't have a digital oscope and you're working with an analog oscope, you'll need to manipulate your times and your volts per division control until you get a signal on your screen. Now, I know this might look confusing to you, but we really do have our input wave here, and then this bottom one is our spectrum analyzer. So that right there is our frequency. And if you look at the generator, you can see we're at 1 meg, and we're at negative 10 dB down, which is really low in voltage. And we have a signal. But we're not seeing anything on here. Why? Well, because again, 1 megahertz is outside of our range. Just for the heck of it, since we do have this here, let's confirm that we are reading 1 megs, and you see the marker sitting there moving. And sure enough, it's passing a 1 meg signal. Very interesting. So, looking at your equalizer, how you test this out. If you look at your equalizer here, you're going to notice on the bottom, at least on mine, and probably on yours as well, it's marked with the frequency of which one of these sliders control. And this one covers 31, 62, 125, 250, 500 hertz, 1000 hertz, 2000, 4000, 8000, and 16,000 hertz. And if we look at our display, it also represents or displays that as well. The other numbers that we see here on the side of the screen, that's marked in decibels. And we have the reciprocating decibels here on the sides as well. What we're going to do is we're going to take that low number of 31 Hertz. And we're going to change this. Let's change this to 0 dB. Whoops, doggone it. Okay. Now if we come down and look at our equalizer, we can see it is passing a signal. In fact, we could see that the 31 and the 62 is really strong, and then the 125 and 250 is illuminated as well. What we need to do is actually set these all in the neutral position. There's going to be a what's called a detent. You'll feel a little notch, and that notch is a detent. Okay, and if you took it all the way down, then you're going to be negative 12 dB. So we're going from a negative 12 dB to a plus 12 dB. And we're not really going to check this for accuracy per se. We just want to see if it's passing the appropriate signal. Okay. So we got that all in line, and now you can see how the equalizer changed after the fact. So why is 62 illuminated? Well, that's top secret, and I can't tell you. No, we could be getting too much signal that's bleeding over into 62. It's very plausible our input signal is really high for that. Could be responding just fine. The input pattern could be a wide signal and not very narrow. A couple of cheesy guesses. Could be also that since this is a consumer grade equalizer, that it's inferior. It don't have enough filterings, narrow filterings to control that. I guess one guess is as good as any. So let's come back over to our oscilloscope. Now in this video we're not going to use the old HP spectrum analyzer, just to save a little bit of time. We're going to use the one that's here on the O-scope, and that's what this bottom one is right here. This is our spectrum analyzer, and with this one we can see a little bit further, and so you can see right here this point. That point's going to represent probably where we're going. Let's go ahead and push our auto setup, and if you've got a manual you'll need to manually do this. Okay, so what do we see? Well, we're seeing one channel configuration does not match the other, and I'm not sure why auto did that. So let's go ahead, and we want to configure this channel because it's the predominant one, right? And we want to see what happens. So we need to tell it we want that channel, and we need to turn our volts down. Oops. Apologize. We want channel 1, and then turn the volts down. Ah, look at that. Okay, so right here we see, even though we're configured where we're supposed to be, our channels are not equal. Well, it could be. Hold on. Let me adjust my offset. Okay. I just lost my screen. Stand by. Wow. Okay. That was weird. Okay. So now we've got the patterns laying on top of one another. And you can see that just down here at the bottom we have a little, the other channel is just a little bit stronger. But I'm not going to worry about that. So now we want to go to our spectrum analyzer, and we want to see what frequency we're at. So we're going to take our marker, which is this little guy right here, and we take to the top, and when that marker changes, that's when we hit the peak there. And now let's come down here to our frequency counter. It says 30 Hertz. Well, I'm sure if we were to widen this out, we would get 31 Hertz. So this is just a functionality of the oscope. We'll put it on a frequency counter to confirm that yes, we are at 31. And there we go. So we can confirm that yes, we are at our chosen frequency of 31 Hertz. Now, if we want to look at this on a sensitive AC meter, you can see that it does work. Now, even though the AC meter will work to show you that you've got output, as you see, it's not going to show you your frequency, nor will it compare the two channels to each other. If you wanted to compare the two channels to each other, then you'll have to find a mark on your meter and then plug the two channels in and see if they do hit that mark. So could we have something else up here that could be causing any of this to happen? Well, I know you can't read the buttons, but let's push them to find out. Yes, this one right here, this EQ record, as you see, it changes this and it changes this. In fact, both of these lines, both of these patterns are now exact. So we could also look at this with our XY, which we saw in the last video. Okay. So now you see that we do have matching signal. If I push this button here, not enough to make the XY really change. Now what if we hit bypass? Well, not much really. And then the next button, well, apparently that's a dummy button. So image enhancer, this one adds a little bit of body to the signal. Wow. And that, as you saw, we brought up the equalizer, and we definitely got a lot more gain out of the scope. Now this control right here is our image, our enhanced level, so I think it might control that a little bit. And if you notice on the spectrum analyzer, when I adjust that, you can see that it also moves. And then this is our tape monitor for 1 and 2. We don't have anything plugged into it, but as you see, when I push that, it kills it. Kills it. This is for tape dubbing. No change and no change. And then we have this control, which is our display level. It should only affect our display, which it does. So if I adjust it where we get rid of that 6.2, which is probably what I should have did anyway, because you see that it's setting at 0 dB. So that's another option that I didn't think of. And it just barely got that cracked. Okay, awesome. Now what happens if you adjust this? Well, it's going to shape the signal. The 31 Hertz, this lower section all has to deal with bass. And you can see by adjusting that, and this is why I've said all along throughout this series, make sure everything is in neutral, because as you see, it really does affect your signal. And when you're trying to calibrate a device, if you calibrate it with things not in the neutral position, you're not going to get it exactly calibrated. Next signal to look at is 62 Hertz. And so we'll go to 60. Oops. I always forget to put my marker where I want it. So 62 Hertz. We're still 0 dB. And we come down, we look at the scope, signal looks good, and now you see 62 is predominant. And we're actually just a little above the 0 dB, so let me adjust that with our display level. And if we go to our spectrum analyzer, let me bring that down so we could see a little better. Okay, so now we could see that better. Let's change our position. And as we can see, 60 Hertz. Let's just go ahead and jump forward to 1000 Hertz. And now our scope looks like that, and our equalizer looks like that. We're going to adjust the gain, bring that down to 0 dB. And as you see, when we bring, apologize for it being out of focus, when we brought it down to 0 dB, the other bands went away, and we have a clean signal there. So now we need to come back over here, recalibrate our scope. We'll hit our auto button. And for those that don't have an auto button, you have to control it with your knobs. Now we look at it. Let me bring our graph back up. That is a very, very strong signal. And now we'll set our marker. And we have 1000 Hertz. And if we take this to the frequency counter, we should see and there's a little bit of a signal. So let's go ahead and plug this back in. Now we're not going to do all frequencies on the spectrum analyzer. I think you get the gist of it. It's something that you'd want to go through and check each one to ensure that they're all responding, and if not, then you'll know which band you need to troubleshoot. So on a spectrum analyzer, if you're not all that familiar of configuration, the low part of it is going to be bass, the center part is going to be mid-range, and the high end will be treble. So when you configure this, when you're adjusting your sliders, the way how I adjust my sliders, I'll start with one end. I'll start with one over here, adjust it, and then I'll come over to here and I'll adjust that, and I'll just keep walking through the bands until I meet in the center. Like I said, this end is going to be bass. This end is going to be your treble, and the center is going to be mid-range. So when you get to 1000 is going to be for your vocals, for your voice. And if you've never adjusted an equalizer before, the way how I adjust an equalizer is essentially by ear. I turn up the volume on the stereo really loud, not where it distorts. Make sure everything's neutral on the stereo and on the equalizer. Bring it all to neutral, turn it up high, like I said, just before it distorts. Bring it down a notch or two. On the stereo, I'll make my adjustments for bass and treble. The equalizer, then I'll reshape the signal and give it just that extra little bounce, that extra little body. With your ear, when you're adjusting your equalizer, you're going to listen for what's called flat topping, or the envelope. You're going to hear the envelope just kind of change into a weird oddity, flat topping. It's not going to sound good. When that happens, bring down your control, your slider, just past that where it starts to sound good again. and then you move on to your next one. And you may need to do this a couple of times, both on your stereo and your equalizer, until it sounds good to you. And that's what you want to do, make it sound good to you. So the next one we're going to do, and the last one, we're going to go all the way to the end, which is 16,000 Hertz. And again, it's all treble. So if you're into country music, this is where you want to be. Nothing but 16,000 watts of pure treble. And now we see that, and we see this. Now we are actually just a little low on our signal, so we'll adjust this. And as you see, when we hit that 0 dB, it brings up the 8,000. And let's auto config this. And then we'll bring our marker. Okay, so we got the little top hat thing, and then we can see 16,000 Hertz. Walk it to the frequency counter. Hertz, and then for what the heck, we'll plug it in on here, and we got a signal. Now, once you get your equalizer and everything adjusted the way you want it, then you'll go through and adjust your expander or any other noise makers that you have, and then you'll kick back and enjoy your music. Now, also when I'm configuring my bass and my treble and my equalizer, I'll have a myriad of tapes, a bunch of different tapes, different genres, things that I may like, things that I may not like. And I do this for the sole purpose of testing to make sure all the ranges are set, or if any's going to distort on any certain genre of music, then I know how to adjust it, turn it down or turn it higher. Even though I was joking about the country music high treble, this is really true. Most of your country music, classic country, is going to have more mid-range, more treble. Modern day country, I'm noticing that they're turning up the bass a little bit and the guitar. So you're going to hear a lot of mid-range and some lows with that. Now there will be some vintage country music that definitely does have some awesome lows. And then you'll want to listen to pop music, and believe it or not, you want to sample some rap music. Regardless how you feel about the genre, it has a lot of good bass into it, and it'll help you configure your equalizer accordingly. And then once you get that all set up, no matter what you feel like at the moment of listening to, your stereo system will sound just fine. Now, we did not talk about servicing the equalizer. How do you do that? Again, that's beyond the scope, but there should be some controls on the inside. I've not opened this one up to confirm, but there are probably controls in there that may calibrate each one of these. If it's not done by control, then it's going to be done by capacitor, resistor, network, and that's how you'll take care of that. Service manual will tell you how to do that. I don't have the service manual at the time of recording, so I can't tell you for sure on this one. Well, that will end this video. I think we've covered it enough. This was kind of cool. I hope you enjoyed how to do this. I did. Don't get to do this a lot on camera. So thank you for watching. I hope you enjoyed the series. I hope the series was very helpful to you. If it was helpful to you, please pass it on to a friend or those that you think could benefit from this series or any one of the videos from this series. Thanks for watching, and we will catch you in the next video. Take care now.